So in this example, this is question number 16, and make sure that, so in question number 16, right, we have a charge of 5 coulombs, and it has a mass of equals, what, 2 point, so I'm always assuming it's 2 because it's 2.0 kilograms. 0 versus 5.0 coulombs, 2.0 kilograms. And the electric field strength, right, is given as, the electric field strength is given as 4I plus 2J minus 8K. 4I, 4.0I plus 2.0J minus 8.0K. Okay, so it's in, electric field strength is in newtons per coulomb. Okay, so it's 4.0 newtons per coulomb in the I direction, 2.0 coulombs newtons per coulomb in the J direction, negative 8.0 coulombs in the K direction. Okay, and we're told to find the acceleration of the particle. So find A. Particle. And we're also told that the initial velocity of the particle, VO, so this is what's given. VO is given as the velocity vector. It's traveling at 3I 1J minus 3. So 3I plus 1J minus 3K. So it's traveling 3 meters per second in the I direction, 1 meter per second in the J, negative 3 meters in the K direction. And find the acceleration of the particle if the initial velocity is given. What is the velocity at t equals 3 seconds? Anyway, let's go to find the acceleration A first before I continue. So let's find the acceleration. The acceleration, right? The force on the particle is given by mass times acceleration vector. A is what I'm trying to find. But that force, right, is also the charge of the particle, which is Q, which is 5. Actually, I'll use a capital Q. Yeah, we're using capital Q. Times the electric field strength. So this is Q times the electric field strength. So we can solve the acceleration vector. So the acceleration vector is going to be Q times the electric field divisible by the mass. In this case, Q happens to be 5.0 times the electric field, which is 4.0I plus 2.0J minus 8.0K, all divisible by 2.0. Nice easy numbers. So that's your acceleration vector. So we can write this as, well, nice round number. So it's 5 times 4, 20, 25 by 10, so this is 10I. And 5 times 2 is 10, divided by 2 is plus 5J. And there's an 8, so 5 times 8 is 40. 40 divided by 2 is 20, so minus 20K. So the acceleration of this particle will be 10 meters per second in the meters per second squared in the I direction, 5 meters per second squared in the J, and negative 20 meters per second squared in the K direction. So this is your acceleration vector. Okay, so we're also told that the initial velocity is VO, and find the velocity find V at time of 3 seconds, 3.0 seconds. Okay, so what equation we're going to be using? We're going to be using saying that the velocity vector is the initial velocity vector plus the acceleration vector times time. So the initial velocity vector happens to be 3I plus 1J minus 3K, plus the acceleration vector is 10I plus 5J minus 20K, and time is 3 seconds, so this is 3 So we just have to calculate this. I'll just do it in one shot. So this is the I component. I component is 3 plus 10 times 3 plus the j component is going to be 1 plus 5 times 3. And here's your k component. K component is minus 3 plus minus 20 times 3. So in this case it happens to be 30 plus 3, so it's 33i. And the j component is 15 plus 1, so 16j, plus the k component is minus 3, minus 60, so minus 63. So this is a velocity, so it's 33 meters per second in the I direction, 16 meters per second in the j direction, and negative 63 meters per second in the k direction. Okay, we're also asked what is the position at time if the initial position is at the origin. So we're told, so I'm going to have to erase something. So we have VO, we have the acceleration. That's a constant acceleration, it's no function of time, so we can use our second equation. So let me erase this. So we're also told that the initial position vector is 0i at the origin, so 0j plus 0k. Some people just say 0 for simplicity. So the position vector after a time, what is the position after t equals 3 seconds? So is equal to RO plus VO times time plus 1/2 times acceleration times t squared. In this case, RO is 0, 0, so I'm going to put it in. So VO happens to be 3i plus 1j minus 3k times a time of 3 seconds plus 1/2. Acceleration is given by 10i plus 5j minus 20k times t squared. T squared is 3 squared. And I'll just expand in the I component. So here's your I component, which is 3. And then there's an I component over here, which is 9 times 10 divided by 2. So 90, so this is 45. And the j component is 3 times, oops, I made a mistake. So 3 times 3 is 9, so this is supposed to be 9. Let's double check the I component. So this is 10 times 9, 90 divided by 2 is 45, so that's correct. 9 is 45. Here's the j component, which is 1 times 3, so that's 3. And the j component here is 5 times 3 squared, 9 times 5 is 45, 45 divided by 2. And I'm just going to say 45 divided by 2. And the k component is minus 3 times 9, so this is minus 9. And so this will be minus 20 times 9. So 20 times 9 is 180. Negative divided by 2, so it's minus 180 divided by 2 is minus 90. Okay, and I won't reduce this any further, but generally, so evaluate these numbers and we'll get yourself an answer for the position vector of saying this is really, I position is 9 plus 45 or 54 meters in the I direction, and blah 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 and so on. Yeah, it's okay. So this is problem number 16.